Dear friend, I hope our great lineup of speakers is keeping you all engaged and curious. Continuing thus, we have the honor to welcome an all-star telecommunications security expert. I bet all of you have already heard of 2FA, and of course, all of you know why using SMS as a second factor is rubbish. But do you know why? Our next speaker, Sergey, knows all about the vulnerability of mobile network and will be sharing them with us.
Hello, Lihak. Nice to meet you. Let me introduce myself. My name is Sergey Puzankov. I work at Positive Technologies as a telecom security expert. Later, I worked at telecom equipment vendor as a support engineer. I worked as a quality engineer in a big multinational mobile operator, and at my current position, I research signaling protocols from security point of view, seek vulnerabilities, contribute all my findings to non-commercial organizations like GSMA and ITU, and also I share my knowledges at different security conferences. So, object of my talk is SS7, and what the S7 is. S7 is a set of telephony protocols. So this is not one protocol, but a number of them that primarily intended to set up and release telephony calls. But later, when mobile telephony appeared, SS7 is used to process SMS messages, to provide subscriber mobility, roaming capabilities, and some other services related to mobile networks. An elementary portion in SS7 signaling is a message or a signaling message. I will use this term throughout all the presentation. When I will say message, that means not SMS message, it means signaling message or SS7 message. SS7 messages or SS7 traffic goes only within operator premises, between equipment, between network elements, not on the user side. And the same traffic goes between mobile or other telephone operators. Nowadays, SS7 is used in fixed telephony, in mobile telephony of 2 and 3G second and third generations like GSM and UMTS, and for interconnection with LTE networks. So, there is an opinion that SS7 is an obsolete technology. Tomorrow or the day after tomorrow, all we will use 4 and 5G mobile devices. But if we look at the official GSMA statistics, we are somewhere here at this point. We will look that about 5 billion subscribers are still use 2 and 3G networks, 2 and 3G devices. So each of 5 billion subscribers could be attacked by a SS7 hacker. Once a hacker appears in the SS7 in any mobile operator, they are able to attack subscribers around the world, any subscribers of any mobile operator. And what they can do? They can intercept SMS messages, they can intercept voice calls, They can define location of any mobile subscribers. They can perform DOS attacks on subscribers and on the whole networks. They can steal money from subscribers' accounts. And also they can get access to the digital identity of any subscriber, like email, messengers, social networks, and so on. Why the SS7 is not secure? When SS7 was developed, it supposed to be absolutely isolated network. And there was no thoughts to implement any security mechanisms on the SS7 protocols. But later, SecTran specification was introduced that allowed to send signaling or SS7 traffic via IP networks. So SS7 stopped being isolated. And moreover, in 19th, mobile operators got widespread. So the traffic in signal networks rapidly increased, and the number of players in market who was connected to the SS7 also increased. And nowadays we can see a lot of telephony providers, mobile operators, virtual mobile operators, value-added service providers, and other companies who connected to SS7. So the trust era in SS7 in signal networks is over. Mobile operators, fortunately, are aware of this problem, and they do a lot to protect their networks. They install SSL firewalls, install SMS home routing solutions, they introduce signaling intrusion detection systems, they configure network equipment in compliance with security, and also they perform independent security assessment from the external connections. So, I will use some terms, some identities, some abbreviations throughout the presentation, and I need to describe all of them. MSSDN. This is identifier with a long abbreviation, is just a telephony number. The second identifier is GT, or global title. Global title is address of network element in mobile networks. IMSI, International Mobile Subscriber Identity. This is identity of a SIM card. And nodes. STP, Signal Transfer Point. This node is intended to route or switch signaling traffic. HLR. HLR is a database. It stands for Home Location Register. HLR contains information about all subscribers, including identities like IMSI and MSSDN, number of prohibited and allowed services of a particular subscriber, and some technical information. Next network element is MSC and VLR. This element performs two functions. First is MSC, Mobile Switching Center. This node processes voice calls and SMS. And VLR, Visited Location Register. This is also a database that contains information about all subscribers who are active at the moment in the coverage area of the respective MSC. And SMSC, SMS Center. This node is responsible for SMS delivering and sending. And since the object is SSL, I need to explain some of protocols, some of layers. I omit low-layer protocols because they are responsible for physical connections and neighboring communications between network elements. And the lowest layer that is used on the international communications is SCCP, Signal Connection Control Part. This layer of this protocol is responsible for the routing of signal messages using global titles as identities. The next protocol is TCAP, Transaction Capabilities Application Part. This protocol is responsible to tie single request and response into one whole dialogue. And also, TCAP defines application of the upper layer. Upper layer usually is MAP or mobile application part. This is a payload of a signaling message that contains operation code and some other parameters that are related to each operation. For example, IMSI identity, MSISDN identity, profile data, and so on. Signaling network have their own unique security tools. The signal transfer point. This node is able to block some signal traffic via simple rules. SMS home routing. This is not node, but this is a whole solution that intended to primarily to prevent SMS spam and fraud and to hide IMSI identities for the external connections. And SS7 firewalls. SS7 firewall is the most sophisticated security tool that is able to correlate data between different layers of signal messages and find illegitimate traffic at all SS7 messages. Some details about each of these security tools. Signal transfer point. As I previously said, this is a router of signaling traffic, and usually this node is used as a border point of a mobile operator. So it is reasonable to bring in some security mechanisms into the border device. But usually STP is able to block some traffic only using only simple rules. For example, block source by the global title, or block some number of signal messages by operation code, and so on. SMS home routing. Before I describe how SMS home routing works, I would like to describe SMS delivery process. When some SMS center has the SMS for subscriber, SMS Center does not know where this subscriber is located because all subscribers in mobile networks are also mobile, and they can be at any location around the world. So SMS Center, first of all, should receive some signaling, some routing information for SMS delivery. It sends routing info for SM signal message that comes to the HLR database. HLR always knows where subscriber is located, at least it knows current MSC address, and it replies with two parameters, with subscriber's IMSI and the address of the current MSC. Now SMS Center knows where to send the SMS, and it delivers this SMS to the MSC, and after that MSC delivers this SMS to the subscriber. When intruder appears in a SSL network, they can use this dialog, send routing info for SM, request and receive response, to get IMSI identity and address of current MSC. SMS home routing introduces one more network element that calls SMS router. And now, STP, when STP receives send routing info for SM signal message from external connection, it should deliver this message not to the HLR, but to the SMS router. SMS router generates some fake IMSI with random digits and uses its own address instead of MSC's one. SMS Center delivers this message, SMS message, to the SMS router, and after that SMS router performs the second HLR interrogation process. It send routing info for SM, HLR replies with real identities, with real IMSI and the real MSC address, and after that SMS router correlates fake generated IMSI with real MSSDN and delivers SMS message to the MSC and after that to the subscriber. We have two SMS delivery processes. First of them is external and second one is fully internal. And now, if intruder appears in the SS7 and want to retrieve IMSI, STP sends route info for SM request to the SMS router. SMS router replies with fake data, so the network is protected. And the third security tool in mobile networks is SM Firewall. Usually SM Firewall is installed in loop mode. When STP receives some signal message, STP sends it to the SM Firewall, and SM Firewall inspects this message layer by layer, correlating data from different layers, maybe having its own database with some information. If SM Firewall defines the message is illegitimate, it just blocks it. Otherwise, SM Firewall sends this message back to the STP, and the STP delivers to the destination node. All the SM firewalls are based on GSMA categories. GSMA inspected all the potentially hostile SS7 messages and split them into three categories. Category 1 contains information, contains a list of operations that are available only for internal exchange, not for external. Category 2 contains a list of messages that are available on the external connections, but they are related to inbound roamers. And the category 3 is also available on the interconnections, and these signal messages of these categories are legal only for outbound roamers. So now I will describe several attacks, and to make this story more interesting, our intruder will use different vulnerabilities to exploit or to do some of attacks. First attack, IMSI disclosure. What's the IMSI and why intruder needs this information? IMSI itself is not valuable for an intruder, but when intruder knows this information, they are able to perform more sophisticated attack, like location tracking, SMS interception, voice call interception, and etc. Let's look at TCAP protocol. This protocol consists of several fields. First one is TCAP message type. This is mandatory field. The second one is transaction ID. This is also mandatory field. The third, this is not field, but a block of fields. And this block is optional. It contains one of parameters application context name. This application context name defines the operation that that is in the next block component portion, and this is a map operation of map protocol. More details about SMS delivery. For each SMS, we need originating party and terminating party. Originating party sends SMS in MO, mobile originating, forward SM, signal and message. When SMS Center receives this message, it performs well-known HLR interrogation procedure receives information about terminating subscriber and sends the next signal message, MT forward SM, mobile terminating forward SM, to deliver SMS to the subscriber. When SMS is delivered, terminating MSC sends a return result last. The same signal message comes to the originating MSC, and SMS delivery is over. So, intruders use this signal exchange to send a lot of spam through SS7. They might send a more forward SM signal message spoofing source address. After that, all the signal exchange goes by the scenario. And the last component, last signal message, comes to the originating MSC. Why to the originating MSC? Because intruder spoofed this address as a source. To protect SMS spam, TCAP handshake was introduced as a standard. And now, when MSC wants to send SMS, it sends TCAP begin message with application context only that is related to originating MSC. SMS Center should send TCAP continue, that means please proceed this transaction. After that, MSC sends a more forward SM signal message with the SMS itself within the same transaction. After that, SMS Center performs HLR interrogation procedure and performs the second SMS delivery part, terminating part. It could also send TCAP begin message also with application context parameter that is related to the terminating SMS. MSC sends TCAP continue, that means please proceed. And after that, SMS Center sends MT forward SM or the SMS itself. TCAP handshake is available only between MSC node and SMS centers. No other elements, network elements, could not process this feature. But if intruder knows signaling protocols very well, they are able to send TCAP begin signal message with application context that is related to the send routing info for SM procedure operation. STP, when STP processes this signal message, it finds, first of all, destination node. This is the HLR. It is on the SCCP layer. It finds application context name on the TCAP layer, but there is no map operation here. But map, this is a trigger to send signal message to the SMS router and involve SMS home routing procedure. So it is no operation code, no SMS home routing procedure. STP sends this signal message to the HLR directly. And big surprise, HLR sends continue, that means please proceed this operation. After that, intruder is able to send routing info for SM request within the installed transaction. And since the transaction has been installed, STP does not send this signal message to the SMS router. It sends it again to the HLR. And HLR replies with correct data with IMSI and MSC identities, with real identities. Now intruder knows some confidential information like IMSI and MSC, and intruder needs to define location of our target subscriber. Now I'd like to describe identities in signal networks. I mentioned MSSD and global titles. They have the same structure. This identity consists of 3 groups of digits. First one is country code. In this example, France. Second one is network destination code. And the third group of digits defines subscriber if it is a MSSDN, or defines a node if this is a global title. And the second identity, IMSI. IMSI is also consists of three groups of digits. First of them is mobile country code. The second one is mobile network code or operator within this country. And the third group of digits defines a particular subscriber. And now, when we speak about comparison of global title and IMSI, we do not compare these identities digits by digits, because they are from different standards and they have different codes even for countries. First of all, we should find operator for each of identity, and after that compare these two operators. How it works? For example, mobile operator receives a signal message with code provide subscriber info. This is well-known signal message that could be used by intruders to define subscriber location. This is category 2 signal message as per GSMA classification. That means that operator should compare source with subscriber identity. Source is defined by global title. This signal message comes from Switzerland, and this signal message is related to a French subscriber. This is two different operators. That's why this message should be blocked. Look at ITUT recommendation Q773. It defines TCAP formats. And this table shows that all operations could be defined as local and global codes. They have different values, 2 and 6 respectively. And all the signal messages uses this operation code tag. It looks like this in traffic dump. O2 means local operation code, then O1 means length of the operation itself, and 46, this is a hexadecimal code of provide subscriber info operation. And now, if our intruder sends signal message spoofing or changing operation code from local to a global one, even Wireshark cannot decode this message, but we see O6 means this is a global operation code, O1 length, and 46 this is provide subscriber information. STP sends this message to the SS7 firewall. SS7 firewall starts inspection, but it is looking for only for local operation codes, because this is a standard, and it ignores all the other stuff. That's why SS7 firewall sends this message back to the STP, and STP delivers this message to the MSC. And one more interesting thing, what is surprise, MSC replies with normal response, and this normal response is with local operation code value. Also, this response contains information about cell identity. So, intruder receives information about subscriber's location. During our testing, we researched equipment of 4 different telecom vendors, and all they works in this manner. All they responded local value when request was with a global one. Now, our intruder knows subscriber location, but this is not enough for him or for her, and they want to intercept voice calls of our target subscriber. And our intruder will do this exploiting a new DoubleMap vulnerability. How classical voice call interception attack works in mobile networks? Intruder, first of all, should send insert subscriber data signal and message. This message is used to change profile of the subscriber. In this particular attack, intruder should spoof billing platform of the subscriber, changing a real address of the real billing platform to its own address. This one. STP delivers this message to the MSC, and MSC replies with some positive response. That means the profile is updated. After that, intruder just finalizes the transaction, and they're waiting for subscriber to call. When target subscriber calls, information comes to the MSC, and the MSC performs charging process. MSC sends initial DP signaling message to the billing platform, but billing platform is not real. Billing platform is spoofed. And this signal message comes to the intruder. Of course, intruder should not perform billing of this subscriber. Intruder sends connect signal message as a response to this to previous request, and intruder uses PBX address. PBX is a private branch exchange or small telephony switch to redirect call to their own equipment. Call is redirected. After that, intruder is able to initiate one more new call to the target operator. Intruder uses a real identity of these two subscribers because intruder knows all this information from the first signaling message. And when signaling message comes to the operator, call has been established, subscribers are able to communicate each other, but voice traffic goes through the intruder's equipment. Intruder is able to record this talk. Mobile operators are aware of this problem. If a mobile operator has installed signaling firewall, signaling firewall works very well against this kind of attack. When STP sends hostile insert subscriber data signaling message to the signaling firewall inspects source and subscriber identity. And we know that Swiss operator and French operator are two different operators, so SSL Firewall should block this signaling message. Attack is impossible. One more information, one more interesting detail about TCAP protocol. I have already showed this picture with TCAP structure, but component portion could contain more than one component, actually. And each component should contain its own operation code and could use even different identities. When a SSL firewall faces with this kind of messages, and this is not typical message in signal networks, usually a SSL firewall inspects only first component, and it considers that the second one is just a long tail of the first component and ignores this, all this information. And now, how intruder could use this feature of TCAP protocol? Intruder sends DoubleMap, double component signal message to the operator. First component is insert subscriber data operation. The second one is delete subscriber data operation. Insert subscriber data operation does not contain identity of a subscriber. This is okay as per standard. SSL Firewall inspects this signal message. It looks only at the first component. It finds this component is okay, and it sends message to the STP. STP delivers this message to the MSC, and MSC sends return error as a reply. That's okay, yes. This is very strange situation when somebody wants to insert and delete some data simultaneously. This is very stupid request. But what we see, this error goes into cap continue message. That means, I don't understand you. Please repeat your request. And the intruder repeats. Intruder sends double component message again. First component is insert subscriber data without subscriber identities. And the second component is again insert subscriber data with subscriber identity with spoofed billing platform. This message comes to the SSL Firewall. SSL Firewall again inspects only first component and sends this message to the network. And this message comes to the MSC, and now MSC replies with OK for the first component, OK for the second component. That means profile is updated. After that, intruder finalizes this transaction and is waiting for subscriber to call. Subscriber calls. MSC sends again initial DP signaling message that contains information about A subscriber, B subscriber, and some other technical details about this call. Intruder is able to redirect this voice call to the PBX. Voice call goes to the intruder's PBX. After that, it is redirected back to the operator. Subscribers are able to communicate, but traffic goes through the intruder's equipment. All these findings were contributed to GSMA. GSMA is the Association of all mobile operators, and all this information is in a new version of document in the new guidelines that is effective from May of this year. So, my message to mobile operators: please check your security tools, efficiency of your security tools, as soon as new vulnerability is reported. Then, please use intrusion detection system along with SSL firewalls, because SSL firewalls could not withstand all the scope of attacks. And sometimes intrusion detection system is very useful. Also, do not forget about new vulnerabilities when you configure your equipment. Do not forget about TCAP handshakes and about global operation codes. And please block double component signal messages. And we see only several exceptions of double map messages. Main problems of SS7, of course, first of them is flaws of SS7 architecture. Operators are able to withstand this problem, but configuration mistakes and software bugs are still present. And what we see when we research 4G signaling, diameter protocol that is used for 4G networks, 4G networks has absolutely the same problems what we could see in GSM and UMTS. So security is a big issue for the operators. Thank you for your attention. Please, your question.
Any question?
Hi. As security researchers, how can we access the SS7 network? Which hardware do we need and which software should we use?
We have a partner who allows connection to the SS7, and this partner knows about what we are doing in SS7. And moreover, when we inspect one of any of operator, anytime we have a signature or a paper signed by an operator, that operator allowed to do these actions. So this is partner success to the SS7.
Another question on the left.
Hello,
Take the word.
here. Thank
Go
you
on.
for the talk. Just following the previous question. So the SS7 network is not easily accessible for anybody. Is that what you say?
Excuse me, SS74.
My question is following the previous question. What you mean is that to perform these attacks, you need an access to the SS7 network that I suppose is not easily accessible for anyone. So it can reduce
That's right. Fortunately, SS7 is not available from internet or from public IP networks. This is a big problem for intruders, but we see intruder in SS7 exists.
Thank you for the presentation. My question is regarding the firewall. Why is the policy to accept everything and to reject some few things? Why isn't the opposite? I mean, reject everything, accept only things we want to go through.
What I showed right now, there are some features that sometimes was not covered by security guidelines, and the intruders are able to perform them using some software bugs, configuration mistakes, and so on. So operators should be careful in configuration and choosing maybe network equipment and so on. If that's all, thank you.
The last question? Thank you very much, Sergey. Thank you.